think, yeah, you got that. That'll help. Cool, because if you don't get that, I can't really help you with the next topic. So it's important you kind of really getting that down pat first. And if you're not, please feel free to, shoot me, let me know, because I can just I'll run a little session with you guys after this. Okay, so the majority of people look like they've kind of got it down pat and they're comfortable with that. If not, please let me know and we will come back and do that, because you're going to get lost possibly on this next part. It's sort of that point where you got to go, if you don't get this, you're going to get lost in the next section. All right, let's get on to perpendicular and parallel lines. We'll have a look at that and we'll see how that works. And I'm going to add a little bit to these notes, okay, on here. So we're going to look at another EG and we'll put that on down in the bottom. Yeah, okay. So how to find the equation when perpendicular and parallel lines. When got a perpendicular parallel line. Let's just go choose one straight away. All right, here we go. So let's do this. Too easy. Too easy. Oh, this one looks good. Okay. Let's go with something like that. All right. So find the equation. Let's do this. Perpendicular to the line. How to find the equation when find the equation. How to find. I'll just write a question. Let's do a question. That'll be easier. Find the equation of a straight line that is, let's go with parallel to the equation. So the equation, be good if I spell. Y equals, we'll just make one up. Y equals, let's go with 4x 3 and passes through the point 2, 2, comma, let's go with 10. Okay, so I've kind of visualized that in my mind already, what it's going to be. So if you think about this, this is our EG, okay, another EG. We're going to have a look at this one. I encourage you guys to copy this one down too. So if we want to do this, the first thing, right, that we always want to do on the gradient, it's hidden somewhere. In this case, where is this hidden? This is hidden in the words there. This is hidden in the words. Find the equation of a straight line that is parallel to this equation. If something's parallel, okay, if you're parallel to this, what do we know? Parallel basically means that they're both, they're parallel together. They're both increasing at the same rate. They're not going to decrease. So they're going to have the same gradient. So if it says parallel, I know that basically my gradients are the same. So I'm going to call M1 equals M2, right? So really, what is the gradient? If it's parallel to this equation, well, the gradient is 4. Like that is my gradient there. It's right there. So I know that M1 equals M2, and I know M1 equals 4. So therefore, 4 equals my gradient of my new line. So therefore, I know that is y equals 4x plus c. Because it's parallel to it. It has to have the same gradient to be parallel. Otherwise, it wouldn't rise. It needs to rise and run. You know, it needs to go up 4, across 1, up 4, you know, across another 1. It needs to consistently do that. If it's parallel, this also then needs to go up 4 and across 1. You know, and up 4 and across 1, because they need to be going at the same angle. 0 to 5, if that makes sense to you. Why? Because it says it's parallel. If you guys can tell me that, that'd be good, about why the gradient of this other equation that we're trying to find is 4, 2. Good old subtext. All right, here we go. So the second thing that we need to do is to really, come on, do this. The second thing we need to do is substitute in a point on the graph. Substitute in a point the graph passes through and solve for C. So we know that it passes through point 2. So it passes through the point 210. So I'm going to sub it in. So therefore, what I'm really saying is sub in 2, 10 into y equals 4x plus c. So it's exactly what we've already done. So the only new step is realizing it's parallel and it tells you what the gradient is. It's actually easier to do these questions than finding it off the other ones. So now I've just got to substitute in 210, 10 for y. I do sometimes make a mistake there, so I've just got to double check and slow down. That's something I know I'm careful of, and I've written down in my notes is when I substitute in these coordinates, I sometimes do 2 equals. So I just need to be careful. 4, 2 plus c. I'm just going to double check that. That's x. Yes, that's y. Yes. Okay, I've substituted that incorrectly. 10 equals 8 plus c. Therefore, c equals 2. Therefore, my equation is y equals 4x plus c. And that's how we do it. Now, you're going to find it's going to be even easier in this than some of the questions that you start with. Some of these questions that you'll start with are kind of a bit sad. So, it gives you like, hey, this is the find the equation of the line. We want to find perpendicular given to the line passes through the point. We'll do that one now. Just take that. So any 0 to 5 about how you feel that process of parallel and find an equation. So if it's parallel to this, it obviously has to have the same gradient, and then you've just got to find out where it goes, what the c value is, and then oops, why did I write plus c? And then it should be plus 2. Sorry. And if that makes sense to you guys. If you can give me a bit of feedback, that'd be really good. Yep, thank you. Excellent. Okay, so we're going to look at the next question, which is find the equation of a line that's perpendicular to the given line and passes through the point. Okay, so we'll look at this one. So it could be find the equation of a line that's perpendicular to, you could read it like that, or I could say there's perpendicular, I don't know why I've got the equation twice. There's perpendicular to, let's put it in, this equation. And passes through the point 0, 3. Okay, I don't really like 0, 3 because it's a bit easy. That's already giving you the y-intercept. I'd like to change it. Let's just change it to like 1, 3. Yeah, why not? Make it a bit trickier. Remember, if it was 0, 3, I already know my c value of the equation is going to be y equals mx plus 3 because it was 0, 3. So I just want to do this step and show you how to substitute it in. Sometimes you don't need to substitute it in. In that case, you don't. I'm just going to delete this stuff though. All right, so if it's perpendicular, when we say something's perpendicular, we say it makes a right angle. So the word perpendicular is a bit different. So we're saying, hey, if it's perpendicular, it makes a right angle. That's what we're talking about here, okay? So it's right angle is what we mean perpendicular. Now, to find out this in terms of the gradients, there's a rule that we can use, and I'm going to unpack that and show you why that's the case. But it's basically m1 times m2 equals -1. And how that works, again, we use the gradient of here. So when I'm saying what m1 is, I'm talking about the actual gradient of this line, okay? So I know it's going to be 3 times m2 has to equal -1. Therefore, I divide by 3 on both sides. m2 equals -1 on 3. Therefore, I know my equation is y equals -1 on 3x plus c, which is y equals -x on 3 plus c. Now, that's my first step. Okay, so m1 times m2 equals -1, and that's pretty much the clue there. Well, it is the formula, and we'll unpack that a bit later. But first, I just want to go through why that's the case. Okay, so you've got that. Then your second step is basically just to find C sub in a point the equation goes through, the equation you're trying to find, and solve C. Okay. So we know it goes through 1, 3. So we go sub in 1, 3 into y equals -x on 3 plus c. So it's going to be, I just got to slow down here, 3 for y. I always stuff this up. 1 for x. -1 on 3 plus c. Add a third to both sides. C equals 1 on 3 plus 3, because it's going to be positive. C equals, that's going to be 9 on 3. It's going to be 10 on 3. Therefore, I can write my equation of one of two ways. Y equals -x on 3 plus 10 on 3. Or I could take out a common factor of a third and write as y equals a third 10 minus x. Okay, because I've taken out a common factor of a third. If I multiply that out, that's 10 on 3 minus x on 3, which is the same thing. And that's how we get to our equation on there. So really the same thing. First find out, what your gradient is, okay, using m1 times m2 equals -1. Then substitute a point in and solve for c. Okay. If you could tell me 0 to 5, like how comfortable you feel about that, just using the rule, not understanding why that rule works, but using that rule to find the gradient. That'd be good. Let's save that and upload that to our resources as well. I'm going to show you quickly why that works, that equation as well, while you give me the feedback, and then the rest of the time is for you guys. Okay, I'm going to look at a couple of lines here. Yep, 4.5. Okay, excellent. Good. Okay, I'll run through one more as well at the end before we sort of leave as a summary. So if we look at y equals x, right? If I have something that's perpendicular to that, I've got y equals, say, x plus 2. Like this plus 3, it doesn't matter. You can see that this is like perpendicular to it, okay? So because the gradient here is 1. Now, if I change this gradient to, 2, if I change this gradient here to 2, this one, you'll see that it's not perpendicular. The gradients aren't the same. It crosses over. But if I've changed this to 2, they're both going the same amount. They're both now rising to across 1, rising to across 1. They're never going to touch each other because they're increasing at the same rate. So when it's perpendicular, if I've got to find this line, like if I know this line and another line's perpendicular, I know that's going to be the same gradient. And then I've just got to substitute a point in to find out what the C value is. And sometimes they give you the y-intercept, and it's really easy. If it's perpendicular to it, now some people might go, oh, it's a half. Well, if you think of it like if it's a half, that would be like half x, right? But that doesn't even look perpendicular. If you think about it, they've both got a positive gradient, like they're both going that way. So they're never going to be perpendicular to each other. Let's just stop and think about two equations at the moment. You can actually have like y equals 6, which is horizontal, and perpendicular to that would be something that's vertical. So x equals 5. So these are both perpendicular to each other. One goes up, one goes down. So it kind of has to have that same rotation. How do I get this? Well, some people might think, okay, well, if it's 2, all right, to make it, it might be then -2. Okay, -2x. Whoops, what am I doing? -2x, okay, and we'll turn that on. But again, like as you get steeper with these, and if you make it like -3x, you can see it actually isn't perpendicular with each other. Like the higher this number goes, you know, the less and less perpendicular it becomes, because it's getting -4 is really steep and 4 is really steep. And if you think about what actually 4 is, let's just have a look at this 4 line. That rises up 4 and across 1. So to be perpendicular to that, it would have to run 4 and go up 1, right? To be perpendicular to that. Because if this is rising 4 and going across 1, if I go down 4 and across 1, it's going to be really steep like this, you know. I go down, where are we? We go down 4, plus 4 actually, easier to see. If I go down 4 and across 1, or I go up 4 and across 1. So you can see that these are going really up 2 and across half. This is going down 2 and across half. Now, the angle decreases. So what it actually needs to be is -1/4. That is actually now perpendicular, and it needs to be negative because this is a positive gradient. That's got a negative gradient. If you think about it, if this goes up 4 and across 1, well, this would need to go then across 4 and up 1. Now they're actually in unity, being perpendicular for each other. And that is why the rule is the two gradients times each other need to equal -1, because this needs to be the reciprocal of that. And the reciprocal means you basically flip it upside down as a fraction. So that's 4 on 1, that's 1 on 4, but they need to be the opposite charge. So if that's positive, this needs to be negative. So if I see, you know, y equals 5x, the reciprocal of that would be 1 on 5, right? Because it's, you know, this is actually 5 on 1, okay? So that would have to be 1 on 5, it has to be negative. If this was -5 on 1, this would have to be then, if I flip that, positive 1 on 5. That would be the reciprocal. You can see they're still at right angles to each other. If I've got to say it's -5 on 3, the reciprocal of that would be, flip it over, would be 3 on 5, and that's the positive. If this is +5 on 3, this would be, flip it over, 3 on 5, but the negative. So this needs to be -3 on 5, and you can see it's still perpendicular to each other. So basically, if you've got any number here, just say it's 12, and this is, I don't know, 17, and you want to find the reciprocal of it, you want to find the parallel line to it, flip it over. It's going to be 17 on 12. Oopsies, on 12. And if this is positive, this one has to be negative. Whereas if this was negative, this one would need to be positive. And that's how you get the perpendicular line, and that's why it works. Basically, if you think about, like, if it's rising, you know, if this is rising, if it's falling -12 and running 17, then it has to go the other way. So the only ones that do have the similar lines are y equals, say, x plus 3, and you've got y equals -x plus 3. Now they would be the same because the gradient's 1, and that has to be -1, and that's 12. So hopefully that would help you guys a bit better to understand why that works. 0 to 5 about how you find it. Yep, perpendicular gradient is the negative reciprocal. Yep, and if it's a negative number already, then it's the negative of the negative, which is good. Love it, Harrison. Great comment there. Let's put that in there. Hence, there we go. Go away, black writing. Oh. The perpendicular gradient is negative is a negative of the reciprocal. Love it. Love it, love it, love it, love it, love it. Awesome. So let's go through another example just to sort of sink that in and really speed you guys up with your fluency. So you can use that formula, or it is the negative reciprocal, which we'll put in the dot points up above, which I should have put in there. Let's go through the next one. Oh, these are all too easy. I don't like them because they've got y-intercepts. They're just... So this one, let's do this one. This one's going to be a breeze for you guys, I hope. All right. Okay. So, and what do we want to find? This one. Okay. All right. So basically, you can use the formula, or we can use negative reciprocal. So the reciprocal of this, negative of the reciprocal. Negative 1 on negative 7. Negative negative makes it a positive. M equals 1/7. Or you can do it the other way. And then, so we know it's y equals 1 on 7x plus c. We know that c has to be negative 12. X on 7 minus 12. Good way to check it. If it's perpendicular, this is a negative gradient, that needs to be positive, and it is. That's it. Comfortable using the negative reciprocal, or using no color. Hence the perpendicular gradient is a negative, is the cool. That should help you. That's it. So that you could actually add that, and we should probably add that up in the notes up here. This, or M equals negative reciprocal. As short notes. And I'm going to do negative like negative symbol. You got to put negative symbol and then reciprocal, and then put it in there, and you're done. Expand it, simplify. And say that, yeah. That's it. So add those to your notes, but that's pretty much it. I will upload those to Compass as well. And yeah, there's parallel and perpendicular lines.